Hey guys, it's Mr. Katz. I'm going to go through a video that's going to help you remind you how to use the quadratic formula, but also go through a little through lesson 3. So this is a worksheet that we actually did in class, and I want to go through some of the answers. So one way that you can practice this is if you, without looking at your worksheet, if you can try to answer these questions using this equation, and then watch the video, that's another way that you can help practice. So here, we know that this is in function notation. This is saying what is the function if you put in a 0 in for x. So I could either put in a 0, or really that's the y-intercept, and when x is 0. And we know that if this is in standard form, negative 12 is actually the y-intercept. So I know that when x is 0, y is 12. So f of 0 is equal to negative 12. And same answer if you plug in a 0. Here, f of 2. So I'm going to plug in a 2 into the equation instead of x. And if you solve it, you get 4 plus 8 minus 12, which is 12 minus 12, which is 0. So f of 2 is actually 0. So when y is 0, one of the answers for x is 2. That actually should help us. So right here when it says, what's f of x equals 0? Well, we know for sure that one of the answers is going to be 2. Because when y is 0, we know x is 2. But because this is a quadratic, there's going to be 2 answers. Now, there's a lot of different ways you can solve this, because this is asking for the solutions, the x-intercepts. You can factor this, you can graph this and find the intercepts. There's a lot of things you could do. I'm going to remind you how to do the quadratic formula using these. So here you got a equal to 1, b equal to 4, and c is equal to negative 12. Negative b, well, b is a positive, so that'd be negative 4, plus or minus the square root of b squared, 4 squared. Even if it was negative, it would still be a positive 16, minus 4 times a times c, all over 2 times 1, which is just 2. Here, I'm going to do the stuff inside the discriminant. Think of this as a negative 4 times 1 times negative 12. You get a positive 48. So it's actually going to be 16 plus 48, which gets you 64. So negative 4 plus or minus the square root of 64 equals 2. Now, had this not been a perfect square, I would leave it in the square root sign. But since it is, I could say negative 4 plus the square root of 64 is 8 divided by 2. Negative 4 plus 8 is 4 divided by 2 is 2. And the other answer would be negative 4 minus the square root of 64, which is minus 8, divided by 2. So there you get negative 4 minus 8 is negative 12, divided by 2 is negative 6. So remember, we knew one of our answers was going to be 2, but our answers are x equals 2, and the other answer for x is actually could be negative 6. Normally you write them in negative 6 too, write them from least to greatest. Right here, f of equals 20. So we're going to plug in a 20 in for this instead of a 0. So you get the equation 20 equals. And to solve this using the quadratic formula or factoring, you have to get it equal to 0, the equation. So we're going to subtract 20 on both sides. And when you subtract 20, you get negative 32. Negative 12 minus 20. Well, I'm going to use the quadratic formula again. Or we could have factored. But here I'm just going to use the quadratic formula. Negative b, negative 4, plus or minus the square root of 16b squared minus 4 times a times c. But now c is negative 32. All over 2 times 1, which is 2. So 4 times 1 is negative 4. Negative 4 times negative 32. It's going to be a positive answer, but 32 times 4 is 128. So you have negative 4 plus or minus. It's going to be 16 plus 128. Let me go ahead and add them right here. And you get 144. So this actually, you can take the square root of it. It's going to be 12 divided by 2. So negative 4 plus 12 divided by 2. And negative 4 minus 12 divided by 2. You get the two answers. X is going to be two things. It's going to be 8 divided by 2. It's going to be 4. And x could also be negative 16 divided by 2, negative 8. And that's how you would answer these questions using the quadratic formula. And again, there's many different ways you could have solved that one.